Okay, so the relationship between velocity, acceleration, and speed is this. Whenever acceleration is positive, and I'm going to do this with signs because it's just easier. So whenever acceleration is positive, velocity is going to be, or sorry, not velocity, is going to be, and velocity is negative, when their signs are different, this object is slowing down. So again, if acceleration is still positive, but velocity is also positive, so if the signs are the same, so if we are positive velocity, positive acceleration, then our object is speeding up. When acceleration is negative, obviously there's two choices again. If velocity is also negative, so they have the same sign, again, speeding up. Okay, so basically, minimum that you need to know is whenever the signs are the same, my object is going to be speeding up. Okay, highlighter's not doing what I wanted to do. All right. And then for the last one there, when acceleration is negative and velocity is a different sign, it's positive, then my object is slowing down. So, to break this down with much less words, the signs. You look at the signs. If the signs are the same, if they're both positive or both negative, the object is going to be speeding up. When the signs are different, one of each is, one's positive, one's negative, doesn't matter which one, our object is going to be slowing down. Okay, so now the relationship between velocity and acceleration. If velocity is increasing, so if we're looking at a graph and our slope is positive, so our line is rising like that, or a slope is greater than 0, because numbers greater than 0 are positive, then the acceleration is going to be positive. Now, if the velocity is decreasing, so if I look at my graph and the slope is decreasing, so my slope is less than 0, because numbers less than 0 are negative, then the acceleration is negative. And if the velocity is constant, I actually have a line like this, right? It's just a horizontal line, at which point my slope is 0. And the slope of that is what acceleration is. Notice how I've associated this completely with the slope. Because why would I want to know the slope? Well, what is the acceleration? Acceleration is the derivative of velocity. Since acceleration is the derivative of velocity, I can tell what acceleration is doing by looking at the slopes of the graph of velocity, or the behavior. If it's increasing, positive slope. If it's decreasing, negative slope. If it's constant, 0 slope. And that is what's happening with my acceleration. All right, so here's our graph. So we're going to break this down. This is the velocity time graph. So we're going to indicate the time or times when the object is moving to the right. Okay, so as far as the object moving to the right, if you look at your notes from the previous section, 2.2c, the object is moving to the right whenever velocity is positive. If velocity is positive, then it's moving to the right. Well, it probably is better if you have a visual of this. So this is what I'm going to do. I need to figure out where velocity is positive. So from 0 to 2, so right here, velocity is positive because it's above the x-axis. So I wrote it down. Above the x-axis is positive, below the x-axis is negative. So that's above. Technically, this right here is above, right? All of this. I'm only highlighting it to, I guess to use the word to highlight what is positive, to give you an idea, an understanding. So from, let's see, from 1 to 2, and then from 5 to 12. It's above the x-axis, therefore it is positive. So positive, velocity is positive, velocity is positive for all of that. Actually, let me write it a little differently. Positive, positive. All right. So I'm trying to figure out when is the object moving to the right. It is moving to the right from, I can write this one of two ways. I can write it between, let's see, 0, so t is between 0 and 2, or I can write from 0 to 2. Either way, these intervals are correct. So I can write from 5 to 12, oops, or from 5 to 12. You choose, it doesn't matter. Okay, B, the acceleration is positive. Okay, so again, if you look at the chart, acceleration is going to be positive whenever the velocity is increasing. Okay, so where is the velocity increasing? Oh, that's right. I gotta figure that out. So I'm gonna do that in red. So here I have a positive slope, but then it dips down. Oh, but then here I have positive slope again. And then from 4 to 5 it's constant, so that's not increasing. From 5 to 6 it goes up. 6 to 7 is constant. 7 to 8 it dips down. 8 to 11 is constant. 11 to 12 it dips down. So acceleration is going to be positive whenever the velocity is increasing. So the only places that is increasing is the places I marked red. So from 0 to 2, I'm going to do it as parentheses just because it's faster. From 3 to 4, and from 5 to 6. So those are the places where, oh, I'm sorry, I noticed I put 0 to 2. It's 0 to 1. I don't know why I'm going crazy with the 2. Okay, so those are the only places that it's increasing. And therefore, since velocity is increasing, my slope is increasing, my slope is positive, acceleration is positive. All right, C. I'm looking for where the acceleration is negative. So since I just figured out where it was increasing, now I need to figure out where it's negative. So if I go down here, see this? This is negative. So that's from 1 to 3. And I'll just write it down. Oh, actually, I'll write something else down first. Okay, velocity is decreasing is when the acceleration is negative. So now I'll write it. So from 1 to 3. And then from 4 to 5, still constant. 6 to 7, constant. But 7 and 8, from 7 to 8, it takes a dip. So 7 to 8. And then again at 11 to 12, it takes another dip. So it is decreasing. Therefore, my slope is negative. Okay, part D. I'm going to have to use the new graph over here. Actually, let me copy something real quick. Alright, I copied over the positive. So D says the object is speeding up. So if you look up at the chart, right, recall when is the object going to be speeding up? It's going to be speeding up when the velocity and the acceleration are the same exact sign. So at the very beginning, I figured out velocity. So up here, this is the velocity sign. Well, we figured out where it was increasing. So now, let me do this. I'll do it purple. So it's positive from 0 to 2, but from 2 to 4, it's going to be negative. So negative. And then from, let's see, I did my highlighter. Okay, from 4 to 5, velocity is constant. That means the object is at rest. You could put 0, right? Or at rest, whatever. And then from 5 to 12 is just increasing. Okay, so now I need to figure out the signs for acceleration. So this is how I always do it. I just use the top for velocity. So I'm going to use the bottom of this graph for acceleration. Let me move this out of the way a little. because you've got plenty of space. Alright, so I'm going to pick another highlighter, so green. So I want to look at increasing, decreasing for acceleration. Because remember, if I know the slope, then I know what acceleration is doing. So from 0 to 1 is increasing. So therefore, it's positive. Okay, then I see that my slope is decreasing all the way up to right here. So then that makes this negative. And then from 3 to 4, okay, so I need a highlighter again, my slope is positive again. So positive. From 4 to 5, nothing, oops, I forgot to change the highlighter. Hold on a second. Come on, baby, go away. I need highlighter. Okay, so highlighter. From 4 to 5, nothing's happening because we're at rest. So we're at rest, therefore acceleration is 0. It's not accelerating, right? Okay, so back to from 5 to 6. My slope is positive, right? Because the line is going up. But then from 6 to 7, my acceleration is constant. So when acceleration is constant, again, not accelerating, so 0. Okay, this is a lot more meticulous than the velocity was, right? But not impossible. From 7 to 8, my slope is totally negative. So negative. Oops, I'm missing like some green dots. Okay. From 8 all the way to 11, again, at rest, or sorry, not at rest, 0. And acceleration is 0 because velocity is not increasing or decreasing, it's just constant velocity. They're just cruising. Alright, and then finally, last one. From 11 to 12, my slope is decreasing, therefore acceleration is negative. Oops, I said negative and I wrote positive. Lovely. Okay, so now what we do is we compare. If I want to figure out for D and E, because if you didn't read ahead, I'm trying to figure out when is the object speeding up and when is it slowing down. For speeding up, I'm looking for when is the slope, or sorry, the slope and my velocity the same sign. So I'm going to highlight that with yellow. Okay, I'll do it with the thicker one. Okay, so for D, speeding up. For speeding up, it has to be the same sign. Okay, so here we have positive, but down here we also have positive, right? So from 0 to 1, we have positive. So from 0 to 1, they're the same sign. Okay, from 1 to 2, velocity is positive, but acceleration is negative all the way until 3. So then that brings us to this right here. This is negative, and so is this. So, oops, it erased. Okay, so then that means that since both my velocity and my acceleration have negative signs, then it is speeding up the particle or whatever. So from 2 to 3. Okay, next. Let's see. From 3 to 4, velocity is negative, but acceleration is positive, so that's not going to work. From 4 to 5, velocity and acceleration is 0. There's no speeding up happening here. 5 to 6. Well, actually, from 5 all the way to 12, velocity is positive. So, the only things left for me to look at are whenever acceleration is positive. So here acceleration is positive, and in this interval acceleration is positive, so then these work. Why does it keep erasing? Come on, highlighter. Work with me here. Okay. So I'm going to say from 5 to 6, and I'm also going to say from 7 to 8. Okay. Oh, hold on a second. Did I do something wrong? I did. Why? Oopsie. I must have done it earlier too. That last one? No bueno. Let me just erase it the good old-fashioned way. If you caught my mistake, congratulations, you're paying better attention than what I am to what I'm writing. Velocity is positive from 5 to 12. From 5 to 6, my line is increasing. From 6 to 7, it's constant. From 7 to 8, it's decreasing. I don't know why I put a positive. So that little, oops, that took off too much stuff. Let me just get rid of it. You, my friend, have got to go. Come on, plus sign. I'm trying to get rid of you, plus sign. Okay, I'm going to do it the hard way. Okay, I fixed it. It's a minus. I must have done what I did when I did the interval from 11 to 12. I said minus and I wrote plus. Who knows? Okay, so my object is speeding up only between 0, 1, 2, 3, and 5, 6. I guess really then that means that I did have to get rid of the highlighting, right? But just ignore it. It's a little harder to erase. Well, let's see. Okay, I did it. Alright, so beyond that, now we could do the slowing down. Slowing down, I need to focus on areas where the signs are different. That's what I want to do. So let me do that in, what color I haven't used? I haven't used blue. Okay, so signs are being different over here. Right? Basically, I'm going to look at the stuff I haven't highlighted. So I have plus on top but minus on bottom. So that's one place. If I move on, here I'm minus, but down here I'm plus. 0, 0 doesn't count. This was plus plus. It used to be highlighted. Oops. 0 and plus doesn't count. 0 minus, that totally counts, and that's the one I had messed up on earlier because I wrote down the wrong thing. Plus 0 doesn't count, but plus minus counts. So right there. So here are my intervals. I've got 4 of them this time. So basically from 1 to 2, and then from 3 to 4, from 7 to 8, and from 11 to 12. So again, what did I focus on? Different signs, right? Because that tells me slowing down. And then same signs up here, because that tells me speeding up. All right. F. The object is standing still for more than an instant. So figure out where the velocity is standing still, or sorry, the object is standing still, so the velocity is 0. So that's what this is. Velocity, actually, let me do it the right way. Velocity equals 0. That's what we're looking for here. So the only place was, let me do it in red, right here. So from 4 to 5. Or you can write from 4 in between, okay. Oops, I didn't mean to write that. Okay, so G says the object changes direction. So the object is going to change direction when velocity changes sign. So basically, it's changing direction whenever it changes from being above the x-axis to below, or vice versa. So if we pay attention to that, that occurs here at t equals 2, and somewhere in here. It was below on the left, and then above on the right. So this is not a perfect graph, but we're going to include that too. So we're going to say, let me move that over, between 4 and 5, it changed from being below to above. I didn't see how here I put 1 point. That's because that's where it actually happens. But for the other one, it's kind of weird because it's constant or 0 for a while. So that's why I have to say it happens between 4 and 5. All right, last part is the speed is the greatest. Graph the object speed. So I'm looking for when is the speed the greatest. Speed is going to be the greatest when the velocity, or the absolute value of velocity, is the greatest. Because remember, speed is the absolute value of velocity. So, oops. Okay, greatest. All right. So, easy way to find this is to look at the graph, and I'm going to erase all of this, by the way. So let me just get rid of all this. Okay, yay. So, easy ways to do this is to flip parts of the graph that are below the x-axis above. Just to make sure, so this right here, that needs to flip. It needs to reflect over to the top of the graph. So basically, it becomes this. So now this is my speed graph. That is how you graph speed. You take velocity, and anything that's negative becomes positive. So this red, this is my speed graph. So the only difference between it and the velocity graph, obviously, would be this bottom part. Okay, that does not exist for my speed graph. But anyway, the highest points are up here, right? So I would say that the speed is the greatest from 6 to 7. And I'll do that one, oops, I'll do that one as one of these intervals. Doesn't really matter, I just want to show you both.